Good? All right, so first thing we're going to do today is we're going to quickly write the 5 methods of factoring chart. At this point, you should have this memorized. If you need to cheat and look back at a previous section to write this down, you can go for it, but I had you time me, or some of the students timed me last time. I did it in 40 seconds or 38 or something like that. You should be able to do this in 1 minute. Go ahead and rip it out, right? On the left-hand column, you've got the factoring methods. On the right-hand column, you've got the type of polynomial possible on. First method is pull out CF. Your second is grouping, right? Third is x squared plus bx plus c, where a equals 1. Fourth method is ax squared plus bx plus c, where a does not equal 1. Your fifth method is special cases. And these are to be the type polynomial possible on are all 4, 3, 3, and binomial, okay? I'm going to go ahead and quickly draw that rapidly over here. Okay, here we go. Rip it out. Anybody not signed the quiz or the attendance yet? Let's go ahead, grab that.
Thank you.
If you guys want to pass it over to Paul in the corner there when you're done, that'd be great. Okay? You guys good? Okay, should be done with that. All right, next thing I want you to do. How do we do these 2 problems? Well, one of these problems you definitely have on the board, and we'll discuss it last today. What I want you to do right now is tell me, in that problem right there, 4x squared minus 17x plus 15, okay, what does A equal?
4.
Okay, write it in there, 4. What does B equal? Negative 17. And what does C equal? 15, right? And that's going to be imperative that we know what A, B, and C equal to handle that kind of problem. We're going to go ahead and we're going to pause our 4x squared minus 17x plus 15. 4x squared minus 17x plus 15. All right, I want you to drop your pens. I want you to drop your pencils. I'm not going to teach you anything right now that you need to write down, and none of it will be in the workbook, but I want you to help me with, because on this first page here it says, how did you do these problems? You know, for most of you back in high school, you learned, so when I brought these methods, I told you this method right here, and I used this terrible word, sorry YouTube land, but I'm going to use this word. I said that this method sucks, okay? And I said, how many of you, your mothers tell you don't use that language, you know, and many of you raised your hand. Well, okay, a fraction of you raised your hands, and I can appreciate any. My wife tells my children, don't say that, that's not a nice word, you know. Say, it's not a nice word, but it does suck. But the reality is, okay, this method actually that we're going to learn today, it doesn't suck. This is what sucks. Look up here. Look up here. So, back in high school, so remember the other night we said this had to be x and x to make x squared, right? Because we didn't have the 4 there, everything, you know, a equaled 1. But now, think about it, that could be 4x and x. It also could be 2x and 2x. Does that make sense?
Yeah.
Right? So now you got this double option. Yeah. Because instead of x and x makes x squared, the first 2 things being multiplied have to make 4x squared. Right? So let's think about this. And this is what your teachers taught you way back when you don't even remember your teacher's name or, you know, how much you hated them, but you did. This could be, look up here, this could be plus 15 and plus 1. Okay? So look up here. I could have 4x plus 15 and 4x plus 1. I'm sorry, not 4x, just x. Just x. My bad. Okay, x plus 1. Do you understand why? because your last two terms when multiplied together have to make 15. And you could also have, what else? You could have 4x plus 5 and 4x, or I keep saying 4x, and x, plus 3. Agreed? Because 5 and 3 make 15. Or you could have 4x minus 15 and x minus 1, and you could have 4x minus 5 and x minus 3. Do you get that? Because negative 5, negative 3 make positive 15. Negative 15, negative 1 make positive 15. So those are 4 options you could have. Now you could take all 4 of those options of 15 and 1, and 5 and 3, and negative 15 and negative 1, and negative 5 and negative 3, and you could put them all here too. So now you would have 2x plus 15. And I'm not going to write all these. 2x plus 1, and 2x plus 5, and 2x plus 3, and on and on and on. And you would have 8 options total. In fact, I am going to just write these. So you can have 2x minus 15, and 2x minus 1, and 2x minus 5, and 2x minus 3. Okay? So you actually have up here 8 binomials times binomials that could be the correct answer to make this, because every one of these makes a 4x squared and a positive 15. It's what the middle creates that will determine which one is the correct one. Are we clear?
Yes.
So what do? Well, you multiply. 4x times 4x makes 4x squared. And 4x times 1 makes plus 4x. And 15 and x makes plus 15x. And 15 and 1 makes plus 15. Okay? And my middle terms make what? 19x. And so that is not the right answer, because we need 17x. So you tried, you erred, you try again. And you keep multiplying these out until you find the one that works. Who learned that method in high school? Raise your hand. The trial and error method. Come on, raise your hands. Who learned something like the trial and error method, right? All right. What blows my mind is that this really is the primary method by which you're taught to factor these problems in high school. Okay? Today, we're going to learn what is typically called the AC method amongst mathematicians. I don't call it the AC method. I just call it the and AC would be a much bigger abbreviation. I call it the AX squared plus BX plus C method, where A does not equal 1, because I want you to understand when to use it. Okay? You got a trinomial and A does not equal 1. Okay? So this section here is really just to discuss, how did you do these? All right? Well, maybe you use some of this and I talk about this. There's a reason I take the time to talk about that. How many of you remember that kid in high school that pulled into the high school parking lot in the Porsche or Beamer, or the really fancy vehicle that cost a lot of money? Okay, who in here was that kid? Anybody? Were you, Gentile?
Not a Porsche, but it was a Super Celica.
A Super Celica?
1985.
Okay.
So.
Dude, so here's the deal, man. You're cracking me up.
We're gonna look it up now.
So, what did you feel about that kid?
I hated them.
You hated him. Okay. Why'd you hate him?
I
Because I
passed
love those
unrighteous
cars.
judgment.
You passed unrighteous judgment on him. Okay.
That's better.
Why did you hate him?
Because I wanted that car.
We envied him.
Yeah, I mean, at the end of the day, if we're really going to strip ourselves of everything on the exterior, we were jealous. A little jelly, we were like, and our thought was they didn't earn it. We judge them, oh, he got his daddy's money. Well, how do you know it's not mommy's money? So it was, they didn't earn it, right? It was given to them. So here's the deal. For those of you who have done this method, okay, you've earned the right to learn the method we're going to share today, okay? Because you paid the price. But if you haven't, here's the thing that was tough about that kid. Did that kid really appreciate what they had?
No.
No. And that part sometimes actually did make you hate him. My best friend was that kid, okay? And I loved him, man. His name was Kevin McIntosh. All right?
Of course that's his name.
Why is that his name?
Kevin McIntosh?
Yeah, his name was Kevin McIntosh.
That sounds rich. It just
Okay,
sounds rich.
so check it out. Here's what's funny. Kevin was a big kid, okay, big kid, and red hair, and you know his name is Kevin McIntosh, and we called him Big Mac. Okay.
Okay.
And what's funny is he loved McDonald's. He loved Big Macs, and but his dad was a bank president, and they had a lot of money, and you know I loved hanging out with him, and you know and he had this thing souped up, and you know and then he put a big subwoofer in the back. And he loved rap music. You know, and we'd go driving, and that thing was thumping, boom, boom, boom. You know,
That's
and
style right there.
it was fun to hang out with him. But I remember one time we were driving, and he starts slamming the dashboard. He's like, "I hate this POS." You know, he's calling his car a piece of crap. Well, you know what my car was? I didn't have a car. Okay. I couldn't afford one. My parents weren't going to buy me one. You know what I'm saying? And so, you know, that was the only thing. And I loved Kevin. I loved him. He's such an awesome dude. And it was the only thing that I was just like, Kevin, come on, man. Like, I'd like to just have a car, you know? And so my point is that he didn't appreciate what he had because he didn't have to earn it. And so we're about to teach you a new method here. And if you haven't paid the price to earn this method, you might be slamming your fist against this method and saying, I hate this method. It's a piece of crap. Okay? Because these trinomials are difficult. So let's go ahead and I want everybody on the count of 3 to read step 1. 1, 2, 3. No. You guys definitely are not going to win marching band honors. Okay? You cannot get in unison. That's okay. We'll get there. Okay? So we're going to put the trinomial in descending order. Is this in descending order?
Yes.
Yeah.
Well, yes, it is. And so we don't have to do that. Why do we need it in descending order? Because we need to clearly see what? A, B, and C. All right? So now we're going to do the same thing we did in method 3. We're going to make a chart. But look at our chart's a little bit different. We're not going to say C equals and B equals. We're going to have A times C. And this is why people sometimes call this the AC method, because you're going to multiply A times C. So look up here. We're going to take A and C. You're going to multiply them. And we're going to take, and it's going to equal something. And then we're going to have a B equal statement. So what is A? What is A? 4. And what is C?
15.
And what's 4 times 15? 60. And what does B equal? A negative 17. Very good. Negative 17. So that's a negative 17 right there. All right. And there's our chart. Okay? Now, it says we got to factor their product, A times C, which is 60 in this problem, to find the magic pair of factors when added equal B. So very similar to what we did in method 3. Okay? So far, very similar. Now, how many of you looked ahead and looked at this method and used it? Raise your hands. Okay, so just a handful of you. And I encourage you to do that, and I think that's awesome. I want you to skip to the next page with me. I want you to skip to the next page just for a second. Okay? So, please listen to me. Please trust me on this. We can do this problem in our heads. We do not need a calculator. We can figure this one out in our heads because our times tables are going to take care of us. But I want to tell you that A and C equaling 60 is easy. But tonight, you're going to get AC products that are in the hundreds and even in the thousands. And that's going to be hard. So what I have on the board right here is going to help you tremendously. But you got to pay attention. First thing, in your chart, the A times C, B equals chart, use A and C as your first pair always. So what am I saying? Remember, we come up with a factor pair right here? And I'm telling you, listen, this is critical, don't guess, don't think. use the pair you already have, A and C. Put 4 and 15 right here. What does 4 and 15 make?
60.
When multiply, we got to add them.
Oh,
19. Now we need this to be negative, so how about we go negative and negative? And negative make that a positive, make that negative 19. Are we cool with that? Are we cool with that? Yeah, we have to be cool with that.
I hated something.
Now, listen, this is really critical. So that's your first step. And so just figure out all the negative stuff, but you're going to use A and C. You don't have to think about another factor pair. We're going to start with this factor pair. Now, look at the next thing it says up here. To equal B, does their sum need to be A bigger or B smaller? And right here it says, don't consider negatives on this step. So look up here, please, please, please. If you're looking down, you're never going to get this. This is going to be a foreign language to you if you don't watch what I do here in class. I'm telling you right now, don't worry about that negative, don't worry about that negative. If I have 19 and 17, does B need to be bigger or smaller? My number needs to be smaller to equal B. Get what I'm saying? My number needs to be smaller. Okay. It says right there, if it needs to be smaller, the magic pair lies in between A and C. So look at this. A and C are 4 and 15. And right now, on a scale of 1 to 60, are all the numbers that exist where my magic pair is. You get what I'm saying? Like 60 is my total value. And somewhere between 1 and 60, there's a magic pair that will make this work, or it's prime. And what I'm telling you is, you don't have to guess between 1 and 60, because look at me, you just said that my number needs to be smaller, so the magic pair lies in between. And so that means that 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Because all of these are now non-options. For the simple fact that that number needs to be smaller, because you're forgetting about the negatives now. That number needs to be smaller. It means the magic pair lies in between here. So look up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 2 of those numbers are the magic pair, or this sucker's prime. Well, 2 out of 10. If you understand the laws of probability, you could guess a single number. You have a 20% chance of guessing one of the right numbers. Okay? So now we're not going to just guess. We're going to use our God-given gift of common fetching sense. And we're going to look at our number 60 here. And what kind of numbers would go into 60? Well, things that go into that end in 0 are divisible by what? 5 and 10. So 5 could be an option, 10 could be an option, right? So let's go ahead and do 60 divided by 5. What do we get? 60 divided by 5 is what? Well, you should know this because you know your times tables. It's 12. Well, look at that. 5 and 12. There's the magic pair, and it proves to be true. It lies in between those two numbers, 4 and 15. And 5 and 12, negative 5 and negative 12 make positive 60. When added together, make negative 17. Okay? Now, please pay attention. Okay? We're going to come back. We're going to come back to this little how do we find the magic pair chart in a moment. But we got to go back to our steps of what do we do with this method. And this is where sometimes students start slamming their hand against the dashboard saying, I don't like this method. Okay? And I'm like, well, you can go back and do trial and error method if you don't like this. They're like, no, I hate trial and error method. That one's no good. Okay? So look up here, please. I take 4x squared minus 17x plus 15. And my next step here says, use the magic pair to break the bx term into 2 terms. What does that mean? It means you're going to take negative 17x and you're going to call it negative 5x minus 12x. Where do I get the negative 5 and the negative 12? They are the magic pair. And I'm going to break this x term up into a negative 5x and a negative 12x. What does negative 5x minus 12x make when you combine those like terms? Negative 17x. So are these the same? They are. Now you're going to drop down the positive 15 and drop down the 4x squared. How many terms do you have?
4.
And what do you do when you have 4 terms? You factor by grouping. You now have 4 terms factored by grouping. So we come back to our chart. The first thing we do in every problem is we look for a common factor. We didn't have one. Now, we went down to this method, the AX method, AC method, and we broke it down, but now we have 4 terms, so we got to return to factoring by grouping. So we take this problem and we say, yep, 4x squared minus 5x plus always, we always write plus, negative 12x plus 15. My common factor here is what? X. I put this over x, I put this over x, and I get 4x minus 5. Over here, what's my common factor? Negative 3. I love that you said negative 3. Because I need the first term to be positive. Right now the first term is negative. So I have a negative 3. I put this over negative 3. I put this over negative 3. And I get 4x minus 5. Indeed, my common parentheses is 4x minus 5. And my leftovers are x minus 3. Now I get students sometimes and they say, Brother Rich, what if I had written negative 12 and negative 5 here? Because I totally could have done that. I would have had negative 12 here and negative 5 here. I'm not going to take the time to do that for you. All I'm going to tell you is this. If you have this term here and that term here, you're going to factor everything out, and that parentheses will be here, and this parentheses will be there. That's what's going to happen. You're still going to get the right answer. The parentheses will just be in a different order, and we know they are the same. Question?
You said that, I know it doesn't matter, but will the x minus 3 be in the front, just because it's
The x minus 3 will be in the front if these are rearranged. That's what I'm saying. They will be in a different order. Cool? Yeah, man. Okay. Let's do the next one. Read it to me. I need you guys to read 18x squared what?
minus 3x minus 10?
All right. So, let's do this together. Okay? We check for a common factor. We don't have one. We take a times c. What is a times c? What's a and c? 18 and what? Negative 10. Make sure you got the negative there. That makes negative 180. What does b equal? Negative 3. All right? You with me here? Don't write it. Don't write it. Come on. Come on, come on, come on. You gotta watch this. 18 and negative 10 are a and c. They make negative 180. My number's getting bigger now. Now I can't just do this in my head. I'm really going to need this other thing to help me out here. See? So I'm going to go ahead and I'm going to go to this little thing right here that's guiding us. And quickly, let's look at this. So it says right there again, in your chart, use a and c as your first pair always. So we're going to use 18 and negative 10. Now that's going to make positive 8. I need this number to be negative, so how about we make that the negative, right? Negative 18 and 10 make negative 180. When added together, make negative 8. You cool with that? Okay. Now we forget about the negatives, right? I need 8 to equal 3. So I need my number to be bigger or smaller? So look up here. On a scale of 1 all the way to 180, I have here 10 and 18. If my number needs to be smaller, the magic pair lies outside or in between? See, look at this. If it's bigger, the magic pair lies outside A and C. But if it's smaller, it lies in between. And so check this out. 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7 numbers. And 2 of them are the magic pair. Or this fetcher is P-R-I-M-E. Prime. Okay? So, again, using your God-given gift of common fetching sense, what numbers do you think would be possibilities? Now, I'm going to tell you, I don't like 11 and I don't like 17 because they're prime numbers and I doubt they go into 180. The first number that looks like it might go into 180 is what? 12 might. Okay? It ends in a 0, and things that end in 0 are related to what? 5s and 0s. So maybe what? 15. Okay. So do 180 divided by 12 on your calculator. Go. And it's 15. And that's your magic fetching pair.
Well, yeah, it'd be negative. So.
One of them's got to be negative to make it negative, and we want it to be negative 15 because that'll make negative 3. Are we cool? This doesn't exist in any math book I've ever seen. I came up with this years ago, and it's just a really helpful tool to help you find the magic pair. Okay? So, look up here. Now, we gotta take 18x squared, and we're gonna break negative 3x up, right? You with me here? So we have minus 3x minus 10. We're gonna break negative 3x, and we're gonna call it 12x minus 15x. Understand? Not 12 minus 15, 12x minus 15x, because it still has to be an x term. And then the minus 10 comes down, and the 18x squared comes down. What goes in between them? A plus, because that's a positive. We now have 4 terms, and we're going to factor that by grouping. If you guys are cool, I'm just gonna erase that right there, 180 right there, and we're going to take 18x squared plus 12x, put it into parentheses, put a plus here, and we have negative 15x and minus 10. By the way, after I pull my common factor out of here, what am I going to have to pull out of this? A positive or a negative? A negative, because both these are positive, and I'm going to need the parentheses to be the same, so I'm going to have to pull that negative out. What's my common factor here? Help me out. 6x. Very good. You guys are good at that. Okay, and we end up here with dude, 6x times 3x plus 2. What's my common factor here, everybody?
5.
Yeah, but I want it to be a negative 5 because I want these to both be positive to match this. So I put this over negative 5, this over negative 5, and I do get 3x plus 2. My common parentheses is 3x plus 2, and my leftovers are 6x minus 5. This method is Cadillac. This method is the Porsche. Okay? Trial and error is the GeoPrism method, and we are not going to mess with it. Okay? You guys cool? Okay, we're going to pause for just a second. Okay. Now it's going to get gnarly. So we look at this problem. First thing we do, cancer doctors, whoop, you're going to check for a common fetcher. Do you have one? Look up there. Do you have one? You got to look for one, because you always have to look for one. Do you have one? No, you do not. But A does not equal 1, so you're going to method 4 here. A times C, 35 times negative 44. I'm good, but I'm not that good, so get your calculator out. What does it equal?
1540, negative 15.
Negative 1540, is that what you said?
Yep.
And B equals what? Negative 57. Okay, this is a big fetching number. This would be super hard to find the magic pair, but I'm going to show you how we're going to make it easy. Okay? So, my friends, what pair do I put here to begin with?
35, negative 44.
Always 35 and negative 44. I add them together, I get a negative number, so I don't need to change the signs, and this ends up being negative 9. Now, drop your pens and pencils. I promise you will want to drop your pens and pencils. Look at this, please. Come on, eyes up here, eyes up here. Look, I'm going to forget about these negatives. You're going to want to watch YouTube. You're going to want to watch this.
Watch it.
Okay, trust me. Does this number need to be bigger or smaller? It needs to be bigger. We haven't addressed bigger yet, so that's why I want you to look up here. So between 1 and 1,540, you have 35 to 44 in this little segment right here. And what I'm telling you is, when your number, look up here, when your number needs to be bigger, the magic pair lies where? Outside of A and C, right? This is A, and this is C, and it lies outside. And here's what's cool. Here's what's cool. One of them lies here, and one of them lies here. Always. It always splits. One lies to the left, and one lies to the right. So somewhere between 2 and 34 is one of the numbers. Okay? Now I want you to use that God-given gift of common fetching sense right now, and I want you to look at the nature of this number, 1540. What does that end in?
0.
A 0. And other things that end in 0 or 5s could be options. So what lies between 2 and 34 that you might want to check out?
20.
10, 20, 30, and I like 20. It's in the middle. Okay? So go ahead and do 1540. One of the reasons I like 20, because anything that ends in 20, 40, 60, or 00, or 20, 40, 60, 80, or 00, is divisible by 20. So go ahead and put 20 in. What do you get?
77.
Yeah. And there's your magic pair. Negative 77. That makes negative 57. Dude, 1,540. You found the magic pair that quickly. But this little thing about outside or in between really helps. So now we're going to take this and call this 35x squared. You guys watch this. On this one, are you okay? I'm not going to write the negative 57 right here. I'm just going to break this up right now. I'm going to call this plus 20x and minus 77x. You cool with that? See what I just did? I took negative 57x and I broke it up into two x terms right here, and then I'm going to have minus 44. I have my 4 terms. Y'all okay with that? What did I do? I took negative 57x and I broke it up into these 2 terms. I'm going to take 35x squared plus 20x and put it in a parentheses, put a plus in between, negative 77x and minus 44. What is my common factor here? Quickly. 5x. Put this over 5x, put this over 5x. I get 7x plus 4. What's my common factor here?
11.
And I like negative 11 because these are both negative. I need them to both be positive for the parentheses to be the same. So I take out negative 11, put this over negative 11, put this over negative 11, and I get 7x plus 4. Check it out. My common parentheses is 7x plus 4. My leftovers are 5x minus 11. You just took a monstrous problem and factored it pretty quickly when you really, really think about it. This is more work. This method is more work than any of the other methods because we have this extra number here. And it creates a lot more options that could be realities. It's not as quick and slick as this method here. We just get our magic pair and plug it in and we're done. But this is really, really an effective method to get us where we need to go. Let's do this next problem. I need somebody to read it to me. Okay, I'm ready. 6x to the third. What do we got?
Plus 4x squared and minus 10x.
All right. Am I good to erase this over here, guys? All right, really quick. First thing we do in every problem, according to our cancer doctor chart over there, what do?
Common factor.
We pull out the common factor. Is there a common factor?
Yes.
Well, they're all divisible by 2, and they're all divisible by x. Agreed?
Yeah.
So 2x. Put this over 2x, put this over 2x, put this over 2x. I get 3x squared plus 2x minus 5. Y'all agree with that?
Yes.
Now remember, we got to take that 2x and put it down here so we don't forget it in our answer. But now, a times c is 3 times negative 5 makes negative 15, and b equals 2. Look at this. This is kind of fun. We're going to take the magic pair there of 3 and negative 5. What does that make? What makes negative 2? So all I got to change the negative 3 and the positive 5, that makes 2. I don't need to do the whole does it lie in between or outside because my a and c really are my magic pair. We always start with A and C, okay? So now I take, look up here, I have 3x squared plus 2x minus 5. Because I'm not worried about the original one, I'm worried about this one. I've already taken the 2x out. Now I'm going to break that 2x up into negative 3x and positive 5x because that was my magic pair right here, okay? And then the negative 5 comes down and the 3x squared comes down. I end up with 3x squared minus 3x in parentheses plus 5x minus 5. What's my common factor here? Help me. 3x. Put this over 3x. Put this over 3x. And you get x minus 1. What's my common factor over here? 5. So that plus comes down. I have 5. I put this over 5. I put this over 5. And I get x minus 1. Indeed. Look up here. My common parentheses is x minus 1. Why am I putting it over here? Because I got to have that common factor of 2x. My leftovers are 3x plus 5, and I am done. I'm going to do this last example. I don't really like this pen anymore. I want it to be darker. If you,
Nice.
Yeah.
okay. If you need to go, you always have the prerogative to leave when class is over. If you need to go, pack it up, pack it in. But I'm going to do this last problem. And if you need to go, just quietly exit. If you want to stay and see this problem, you can. If you want to watch it on the YouTube video to see how we do it, we're going to do this problem right now. Here we go. Somebody read it to me.
12m squared
12m squared
minus mn
mn
minus 20n squared.
minus 20n squared. All right. First thing we do is check for a common factor. Do we have one? Yes or no? We don't. We have an M, but that's not an M. An N, but there's no N. Divisible by 2, but not divisible by 2. It looked like we did, but we don't. Look up here, please. We're going to take A times C, which is 12 times negative 20, which makes negative 240. B equals negative 1. Okay? So, we're going to take 12 and negative 20. That makes negative 8. Does that number, now we forget about the negatives, does that number need to be bigger or smaller? 8 needs to be smaller. It needs to be 1 and negative 1. And so we have 1 all the way to 240, and we have 12 and 20. And when our number needs to be smaller, the magic pair lies outside or in between?
In between.
In between. So look up here. We have 13. 14, 15, 16, 17, 18, and 19. We have 1, 2, 3, 4, 5, 6, 7 numbers, and 2 of them are the magic pair, or this sucker is prime. Okay? And so, what do we do here? Let's use our gift of common sense. I want you to tell me, based on the nature of 240, what kind of numbers do you think would go into 240?
We have to have a difference of 1.
Well, they got to have a difference of 1. Yep, that's a really intuitive thing to come up with. But also, this ends in a 0, which means things that relate to ending in 0 would be what?
5, 15.
15. So it's either got to be 14 and 15 or 15 and 16. If it is 15. So get your calculator out, do 240 divided by 15, what do you get?
16.
You get 16. You see how the beauty of this ending in a 0 and that ending in a 5 help guide you to the right one, okay? And then we have 15 and negative 16 makes negative 240. When added together makes negative 1. We're going to take this and call this 12m squared plus 15mn minus 16mn, because we're going to take negative mn and break it up into those two. And then we're going to have minus 20n squared. We're going to call that 12m squared plus 15mn, put it in parentheses, put plus negative 16mn minus 20n squared. Take your time and look at this. What are both of these divisible by? Numerically, 12 and 15 are divisible by?
3.
Okay, I'm going to rewrite this just so it looks really clear. mn, okay?
3.
They're both divisible by 3, and of the letters, what do they share in common? M. So we divide this by 3m and divide this by 3m. Why I tell you to slow down? Whenever you have this mn thing, they look so much alike, they sound alike, we got to take our time. So this becomes, reduce it to 4, what? M. These m's cancel out, plus 5n. Agreed?
Yeah.
What's my common factor here? And by the way, do we need to pull out a negative?
Yes.
Yes.
Why?
Positive and large.
Both those are positive, both those are negative. To get them to be the same, I'm going to have to pull out a negative. So we know we're taking out a negative. Numerically, 16 and 20, what are they both divisible by? 4. And then, letter-wise, what are they both divisible by? N. So we have negative 4n. We put this over negative 4n, and this over negative 4n, and we end up with, what does that make? Negative 16 divided by negative 4 is?
4.
4. The n's cancel, so I'm left with m. Negative over negative makes a positive. 20 divided by 4 makes 5. N squared over n makes n. My common parentheses is 4m plus 5n. My leftovers are 3m minus 4n. Let's say you had put the 16 over here, the 15 over here. So you would have got, look up here, you would have got 12m squared minus 16mn plus 15mn minus 20n squared. Okay, do you get what I'm saying? So if you had written 16 and 15, decided to do it that way, and got negative 1, you would have wrote them this way. You would put parentheses around each of these. I'm going to show you this really fast. Your common factor here would have been 4m. Put this over 4m, put this over 4m, and you would have got 3m, these cancel, minus 4n. Your common parenthesis, or your common factor here would be plus 5 and n, and so you put this over 5n and this over 5n, and this would make 3, these cancel, m, and this would make minus 4n. Your common parentheses would be 3m minus 4n, and your leftovers would be 4m plus 5n. Notice the answer here. Notice the answer here. What's the difference between these answers?
The 4s and the 3s with their variables.
Okay, listen. There is no difference. Is this parentheses the same as that parentheses?
Yes.
Is this parentheses the same as that parentheses? Again, we've talked about this before. What's 2 times 3? What's 2 times 3?
6.
What's 3 times 2? This by times that by, if we change the order of the by's. Now, if we change the numbers, and rearrange inside of the parentheses, it would make it different. But when you're just moving the parentheses, so what I'm saying is, if you don't put this in the same order, all it's going to do is get your parentheses on the opposite side of each other, which is totally fine. You guys have a good one. Thank you.